Let's look at one with radicals, like 23. And limit as x approaches infinity from the square root of x plus 3x squared divided by 4x minus 1. I know you will say, and I did forget something extremely important. I just went ahead and I did not ask you something super important here. I have to come back. I'm sorry. I have to plug it in. I have to plug it in. I need to see what it is. I just jumped ahead and I said, okay, we do this, but I need us to be very conscientious with that. So when t approaches infinity or negative infinity, which of these three terms will be the most powerful one? When t approaches infinity or negative infinity, doesn't matter. Which one will take the lead? It's a silly question. We know that it has to be the leading term, of course. So it will definitely be 6t squared. So these do not matter. They're too small. They're not going to influence anything. So when t approaches negative infinity, where does that piece go?
Towards infinity?
Thank you very much. The same question for the denominator. Of course, the leading term is the one that will lead, right? So when t approaches negative infinity, where does this go? This is non-existent, really. Where does this go? Right. So this is the second indeterminate case that we are looking at. The first indeterminate case was 0 over 0. The second indeterminate case is infinity over infinity. These are the two that we encountered so far out of 7. My apologies, I just jumped ahead. I already had my plan. That's never correct. I have to plug it in to see what it is. Okay, so I plug it in to see what it is. So what do we get? Again, the same question. Inside this square root, which of these two terms will lead? And the other one is non-existent almost.
X squared.
Right, 3x squared, very good. And when x approaches infinity, this approaches infinity. How much is the square root of infinity?
Infinity.
Absolutely, thank you very much. And the denominator will go where?
Would equal infinity.
Excellent. So again, we are encountering the same indeterminate case. We don't know what to expect. The next thing that I will ask is, what do you think we're going to do? And you may say, oh, rationalize. It's not the case of rationalizing in this case. It's the same brute force, factoring out the degree, top and bottom. Okay, so limit as x approaches infinity. What is this? Let's start with the easy part. What is the degree in the denominator? Yes, or 1. Very good. Awesome. What will you give me in parentheses?
4 minus 1x.
Great job. If you understand this, a lot of things will be easy. Very good. Now, I have to keep the square root. That doesn't go away. And please tell me, what is the degree inside? Inside the square root, what do we have?
2.
2. So I have to factor out x squared. The same idea. Please tell me what we have inside the square root. I hope you agree with that. And now I want to refresh our memory on radicals a little bit. the square root of a multiplied by b, if it's multiplication, not if it's addition or subtraction, I can rewrite this as the square root of a multiplied by the square root of b. And that's what I'm going to do. In other words, I'm going to write the square root of x squared multiplied by the square root of 1 over x plus 3, based on this property of square roots or roots in general. So I'll continue from here. So then this is limit. Do not drop the limit operator till the very last step. It will make no sense. So I write the square root of x squared times the square root of 1 over x plus 3. Everything divided by this. And now the question is, what do I do with this piece? And the rest is...
Make it x, since the square root of x squared would just be x.
Careful.
Oh.
You are on the right track. Allow me to explain. The square root of x squared does not equal x. I know we wish that, but it doesn't. The correct answer is the square root of x squared is the absolute value of x, which we know from last time can be x for x greater than or equal to 0, or it can be negative x for x less than 0. So if you put this in your notebook or where you keep your treasures, this is extremely important. Very, very important. So the point I'm making is, if x approaches infinity, I can write the square root of x squared equals x for x approaches infinity. But if x approaches infinity, what will I replace the square root of x squared by?
Absolute value of x.
Careful. That's true, but finally what? Careful. If x is greater than or equal to 0, I replace the square root of x squared by x. If x is less than 0, I have to replace the square root of x squared by
Negative x.
That's it. So because x approaches infinity, I will replace this piece by what again?
Negative x.
It's
I mean negative x.
So if x approaches infinity, I'm sorry. I see. Of course you are confused.
I got tripped up.
Of course you are confused. If I say one thing and I write something else, everyone will be confused. Sorry, my apologies. There are the two situations I'm discussing here. Sorry about that. My fault. So when x approaches infinity, I replace the square root of x squared by x. But if x approaches negative infinity, then I have to replace the square root of x squared by negative x. In our case, this becomes x. I can change, and I cannot write in a function infinity or anything like that. I can only simplify the function. My apologies for that. So is this okay now? So then we continue, and we write limit as x approaches infinity from x, the square root of 1 over x plus 3 over x parentheses 4 minus 1 over x. And now you'll tell me what you know I'm going to do next, for sure. And that is?
Cancel difference.
And now I'm ready to put in the number. How much? Anyone?
The top would be √3.
Excellent.
And the bottom would be 4.
Right. Because we already discussed that in this situation, or positive or negative infinity, this will approach 0. And same thing in this situation, not if it's 3. If it's 3, I can't do that. But if it's infinity, then it's 0. Which means this is not a pure exponential function, irrational function. I have to write y equals the square root of 3 over 4 is a horizontal asymptote at infinity only. Maybe it's on the other side. It's not. But I haven't checked. And it's not the type of function I can conclude. It's a combo. It's a combo of a rational function with radical. So that's a totally different story. I cannot conclude that that is the horizontal asymptote at both ends. Any questions on this? Please remember, the square root of x squared is not x unless you are absolutely certain that x is positive. But if you don't know, there are two possible options. Two possibilities. Okay, we can spend 3 weeks on these limits, but let's look at one more for now, like 30. 1 caught my eye. No, 30 actually. So limit as x approaches negative infinity from the square root of 4x squared plus 3x outside the square root plus 2x. Okay. What do we do the first thing when we see a limit, which I forgot a couple of minutes ago because I had a plan on my mind. Plug it in. Very good. So tell me which is the most powerful here, and only in that one plug in negative infinity and tell me this piece where it's going and then where this piece is going.
They're both heading towards infinity. Oh.
Yes, very good. I love that. Exactly. So what do we conclude? What is it? So the first one goes where? Where does the second one go? Excellent. Here is our third indeterminate case. Indeterminate. By indeterminate, again, we mean anything can happen. We really mean anything. So we had 0 over 0. We had infinity over infinity. And now we have infinity minus infinity. No conclusion can be drawn from there. Indeterminate case. This is our third. Okay, so I'm going to copy because I'm moving on to the next page. So I'm going to copy again. So limit as x approaches negative infinity from the square root of 4x squared plus 3x plus 2x. We know it's another indeterminate case, number 3 for us so far. And what do we do with it? Any suggestion?
Question.
Yes, please, please.
If you put in negative infinity under the square root, then wouldn't it be square root of negative infinity?
Impossible, because I have to square. This is too small. This doesn't count. So x squared, when x approaches negative infinity, x squared times 4 is so much bigger than this that this one is non-existent. And the square root is positive. Very good question. Did everyone understand the question and the answer? Thank you for asking. Everything okay? I wish. Negative infinity minus infinity, I would write the answer immediately, negative infinity, and I'm done, I move on to the next problem. I wish. But it's not possible. It's the indeterminate case, infinity minus infinity, or negative infinity plus infinity, the same thing, doesn't matter. Very good, thank you for asking that. Okay, so then what do we do now? Any suggestions? Any suggestions on what to do, how to address it? We had only one problem similar to this when we applied the same type of procedure.
Would you simplify under the radical?
Very good. You're really helping me with all your questions. Never be afraid to be wrong, please. So the radicals have these properties. Or minus. This cannot ever be simplified. Like this. Ever. It may be some other way, but not like this. Ever. So this is possible. This is possible. With real numbers only. If one of them is imaginary, the whole thing changes. But I can never break a radical if the radicand, this piece is called radicand. If the radicand is a sum or a difference of terms, cannot be simplified. Maybe I can factor something, who knows? And we had that situation a few minutes ago, in which we applied the square, on the previous page, sorry. The square root of a product is the square root of the first factor times multiplied by the square root of the second factor. Maybe by factoring something, but never ever like this. I don't know if that's what you meant, but it was a very good question, and it was perfect timing for me to show this, to refresh your memory. Okay, no, that's not going to work, so we have to think of another procedure.
Do you put everything under the radical?
Say that again. Was it Andrew?
Yeah. Do you put the 2x under the radical?
Very good. I cannot unless it's a factor. Very good. See? You're really saying that the square root of a plus 2x will be the same thing with the square root of a plus 2x, which cannot.
Wouldn't it be the square root of... Oh, no, I realized.
Yeah, we still cannot do anything, even if you change that into the square root of 4x squared if you want, but you're going to get in trouble with negative, right? So, no. We used this procedure last week. Somebody told me, I waited, and somebody said, oh, I know, you have to. And I did that. Okay?
The reciprocal.
Yes! Rationalize! Very good. Rationalize. We normally don't rationalize the numerator. But we have no choice now. We normally rationalize the denominator, but we have no choice. The numerator. And I think last week we did the same thing. We rationalized the numerator anyway. Great job. Of course, I'm going to the third page. I'm sorry, I have to copy it again. And please tell me what do I multiply and divide by. Great job. Thank you.
Would you do the square root of 4x squared plus 3x minus 2x?
Excellent. Great job. That's the conjugate, of course. And careful, please use the formula and tell me what to write at the top. I am going to copy the denominator. And you'll tell me what you get at the top. Very good, well done.
The top would be, wouldn't it just be itself without the radical, so 4x squared plus 3x, and then it would be minus 4x squared?
Excellent, yay! Thank you. Great job. Yes, these two go away. The numerator, oops. Do not drop the limit operator, please. The numerator has nothing to work on. But now I have to come back here. And you'll tell me what I have to factor out and what is the degree of the inside.
X squared.
Excellent. Please tell me what we have in parentheses. Well done. Well done. Thank you. Yes?
4 plus 3 over x.
Great job. Now remember, I have to break this up, this piece, into the square root of x squared times the square root of 4 plus 3 over x. Okay, what now? Let me write this. It's a lot of writing with these, some of these limits, a lot. So this is 3x, and this is the square root of x squared. This is the square root of 4 plus 3 over x, and this is minus 2x. But now, I'm waiting for you to tell me what to do with this. That's the crucial part.
Replace it with negative x.
Yay! Sorry, I didn't mean to sound like a stupid little kid. I'm sorry.
And then wouldn't that make the 3x and the 3x
Has
cancel
nothing
out?
to do with anything. I'm just replacing this by negative x. Sorry, I didn't mean to sound like a little kid. But I'm very excited. The numerator is 3x. The denominator is negative x. Let's stop for a moment. Everyone understands why this is negative x and not x?
No.
Okay? So please speak up. Don't get, you're not bursting my bubble. I can scream again after you understand it. So, because of this, that's why we wrote, and I had that error. I was saying one thing and writing something else. So when x approaches negative infinity, and this is our case, the square root of x squared has to be replaced by negative x. In the previous example, we had positive infinity. That's why we replaced it by x, not by negative x. But here, when x approaches negative infinity, the square root of x squared gets replaced by negative x. Is that better?
Yes, thank you.
Excellent. Because of this, this number dictates. Of course, it's not a number. This symbol dictates. Okay, and then I have the square root of 4 plus 3 over x, and I have minus 2x. Okay. Now, I would like us to factor out the degree. You can say, what degree? What are you talking about? Yeah, I know I shouldn't really say that. Let's say this is a number. It's not. But for a moment, let's say it's a number. What will you factor out from these two terms? Don't look at this one. What will you factor out from these two terms? That's negative x, indeed. So as you see, these are my props. So 3x at the top, negative x at the bottom. So now make it happen. Tell me what to write so that if you ever want to check, you're safe. This times this is that. This times this is that.
Would it be the square root of 4 plus 3 over x out of the square root plus 2?
That's it. Okay, now look at this and tell me, oh, I know what you're going to do. And I promise I'm going to do it. What is it? Of course. And now I'm ready to write the limit. I removed the culprit. I removed the problem. That was the problem because x approaches negative infinity. X was the problem. So the top goes to?
3.
Excellent. The denominator goes to?
Negative 4 radical 4 plus 3 over x minus 2.
Where is this going?
Oh, to 0.
Good. So then the denominator goes to?
Negative 4.
-4. Excellent. So this is negative 3 over 4. So y equals negative 3 over 4 is a horizontal asymptote, definitely at negative infinity only, for sure.